Hello again. What we're going to look at now is, up until now we've been looking at when, I guess, velocity is given as a function of time, or acceleration as a function of time, x as a function of time. These are all okay. We know how to move between these two by differentiating and anti-differentiating. What we're going to look at in this video is when velocity is given as a function of position, or if acceleration is given as a function of velocity. What do we do in these sort of situations? And what's important to remember in this situation is that different ways of writing velocity, different ways of writing acceleration. Remember, we can write velocity as dx dt, and that's the way we do it. Once we've written it as dx dt, we can solve that. We know how to solve that integral. Also, how do we write acceleration? Acceleration is the change of velocity over time. And once we've got that, we can solve this. And so that's what we're looking at here. And I'm just going to crack straight into some examples and have a look at that. Just remember, we're just going to change velocity or acceleration depending on what the question asks for, to change that into something that we want. So let's have a look at this example I'm about to do. And it is like this. A particle moves such that x dot t is equal to 1 plus e to the negative 2x. Find x in terms of t given that t equals 0 when x equals 0. Okay, so what we've got is x dot of t. So let's just rewrite that. That means dx dt. That's what x dot means, equals 1 plus e to the negative 2x. Okay, and so can we solve this? Well, in this form we can't, but because we want the bottom line of our derivative to be the variable, the function, what we need to do is flip this upside down. So dt dx is equal to 1 over 1 plus e to the negative 2x. Okay, so therefore, time is equal to the integral of 1 over 1 plus e to the negative 2x dx. So all you need to do is solve that. Now that makes it sound easy, but looking at this, you might not know how to solve this. How can we manipulate this? We don't actually know at this stage. You can't do a u substitution here or anything like that. But what you can do is a funny little trick where you can just multiply, because you've got e to the negative 2x, let's just multiply everything by e to the 2x. And you'll sort of see what happens. Multiply the top line by e to the 2x, you get e to the 2x. On the bottom line, multiply everything by e to the 2x, so that's e to the 2x. Plus, what happens when you multiply that by e to the 2x? You get 1. And so you end up with something like that. Now the reason I did that is because now I can do a u substitution. What's that down the bottom? What's the derivative of that? Well, it's just half of what's on the top line. So what I can do now is do a u substitution. So you let u be equal to e to the 2x plus 1. Therefore, du dx is equal to 2e to the 2x. Okay, so we're going to use that to substitute in here. Okay, so that's equal to the integral on the bottom line, well that's u. On the top line, e to the 2x, well that's half of du dx, so half du dx. This might be some good revision. And so that's equal to, half comes out the front. Now I'll just do it again, hopefully I don't run out of space. The x's just sort of cancel out. You've got 1 over u du, which is half log e modulus u. Now I'll just write it back in at this stage. U was equal to e to the 2x plus 1. There we go. And plus c. Got a plus c in there as well. Now e to the 2x, that's always positive. Plus 1, that'll always be positive, so we can take that out. Don't need a modulus sign there. So I'll just do it in the next line. We've also got t is equal to 0 when x is equal to 0. So let's use that fact. So therefore, 0 equals half log e bracket. What was x? X was equal to 0, so that's e to the 0 plus 1 plus c. that tells us that c is equal to e to the 0, that's 1 plus 1. So c is equal to negative half log e2. A little bit messy, but there we go. So we just want the function of x, so the t is equal to half log e to x plus 1 minus a half log e2. We can combine that two together, so we'll have half log e, and that will be on the top line, so it will be e to the 2x plus 1 over this on the bottom line, so minus a half log e2, like that. Okay, so that's what it's equal to. That's t, but we want x in terms of t. That's a pain in the bum, and so we're just going to have to rearrange this. So let's do that. So we're going to have to times, so it's 2t, and then we're going to take the exponential, so it's going to be e to the 2t is equal to e to the 2x plus 1 over 2. Therefore, let's times both sides by 2 and subtract 1. You'll get e to the 2x equals 2e to the 2t minus 1, and therefore x equals, we'll take the log, so we've got log e of 2e to the 2t minus 1, and we're going to divide that by 2, so it's half of that. And so that's your function of x. Okay, so a couple of skills going on there, knowing how to change your velocity into dx dt, and then to be just doing the integration of that. Okay, so let's look at another example. Hopefully it's a bit quicker, this one, because that one took a bit of time. So let's have a look at it. Let's say, I'm just going to go quick to the example. We've got acceleration equal to 3 plus v. Okay, something like that. And if the object is at rest at the origin initially, so that just gives us a bunch of different stuff. In other words, its velocity is equal to 0, its position is equal to 0, at times equal to 0, so that's really nice. Okay, let's have a look. Acceleration. At the moment we've got acceleration and velocity here, and what the question will ask, because I haven't written it down yet, is to find, I'll just write a of t, so find a as a function of t, b, find velocity as a function of t, and let's find x as a function of t if I get time. We'll see if I run out of time for the video. Okay, good. So we've got a as a function of v. Because a is a function of v, let's change a to dv dt, the change in velocity over time, so 3 plus v. There we go. How do we solve this? Flip it upside down. T is equal to the integral of 1 over 3 plus v dv. Okay, so that's equal to log e 3 plus v plus c. We know that t is equal to 0 when v is equal to 0, so therefore we've got 0 equals log e3 plus c, therefore c is equal to negative log e3, therefore what have I got? I've lost it. T is equal to, now if that's log e3 plus v minus log e3, that's going to be log e modulus 3 plus v over 3. Okay, so that's my t, but I want to rearrange that for v of t, so let's do that. Therefore, rearrange it, e to the t equals that, then times by 3, so it'll be 3e to the t equals 3 plus v, and there's a modulus in that 3 plus v. Okay, so therefore, rearrange that, we'll have plus or minus 3t, and then we'll minus, so v equals, what did I say, minus 3, so minus 3 plus or minus 3e to the t. Okay, so there we go. Can we check that? Velocities must be equal to 0 when time's equal to 0. So let's just check whether it's plus or minus. Time's equal to 0, that'll be 3. So this must be plus. Okay, equals negative 3. Oops. Equals negative 3 plus 3e to the t. Must be that one. Okay, because of our initial condition. So that's part. Looks like we've solved part B first. That's okay. Now that we've got our velocity, how do we find our acceleration? So part B, we've got our velocity function here. So what will acceleration be equal to? Well, acceleration will just be the derivative, d dt, okay, of negative 3 plus 3e to the t. Take the derivative of that. That's just equal to 3e to the t. There's an acceleration, no problems, easy. And last one we wanted was x of t. So x of t, how do we find x of t? That's the integral of vt, going in that direction. So that's equal to the integral of negative 3 plus 3et dt. Someone's excited outside. That's equal to negative 3t. And what's the integral of that? Plus 3e to the t. Good. And plus some, have we used c yet? We've used c at the top, so I'll go plus d. And do we know its initial position was 0? And so therefore, initial position at times equal to 0 was 0. So therefore, 0 equals 0, that's 0 there, plus 3e to the 0, so that's just plus 3 plus d. Therefore, d is equal to negative 3. Therefore, my function, I've rushed a little bit, I'm sorry, xt is equal to negative 3t plus 3et plus d, so minus 3. There's my x of t. Okay, so that's how to sort of change stuff around using different forms of acceleration and velocity. Have a go. They just take a bit of practice to get used to dealing with the variables.